Hello, this is Mrs. Sturgeon here to talk to you about how to solve a system of equations using elimination when you have to multiply one of the equations in order to solve. So let's go ahead and get started. Now, when you're solving a system of equations, remember that if I start the equation with both x's and y's, I need to end by solving for both x and y. So that's one thing to remember. Another thing is that in order to eliminate a variable, what you essentially need in front of the variables themselves, so the coefficients, so in order for a variable to be eliminated, when you're adding the two equations together, what you need is to have the same numerical value but opposite signs. So what do I mean by that? What I mean is numbers that can be added together that essentially cancel out or just eliminate completely are numbers like this. If I, for example, I'm not actually solving yet, but take -6 and +6. If I add -6 plus 6, I get 0, right? Let's say I add -12 plus 12. I'll get 0, right? So that's what I mean by same numerical value but opposite signs. All right, so that's essentially what I want in order to start solving this problem here. So I notice that I don't have it at this point, right? So in front of the x's, I have a -10 and a -5. Those are not the same number. In front of the y's, I have a 3, I have a -6, also not the same number. So what I need to do is perform multiplication in order for the number to become the same. So what I'm going to do is I'm going to multiply the top equation by 2. Okay, let's play this out so you can see why did I choose to multiply the top equation by 2. Now when you do this, notice I put the whole equation in parentheses. I need to distribute that 2 to every single term, right? So I'm going to perform now that multiplication. So 2 times -10x is -20x. 2 times 3y is equal to +6y, and then 2 times 1 is equal to 2. Okay, the second equation, I will go ahead and just bring it on down. So I'm just copy pasting it down here. 23. Okay, so now if I were to go through and do elimination, so add the two equations together, you'll see what happens. So if I do -20x plus -5x, I get -25x. Then if I do 6y plus -6y, oh my goodness, that cancels out. It eliminates from the equation altogether. So now I only have one variable to solve for. I've got -25x equal to 2 plus 23 is 25. Solve for x. Divide both sides by -25. And you get an answer of x equals -1. Okay, so I've solved successfully for one of my variables. Now I need to go back and solve for the other one. Now, this is where sometimes people get a little confused because they're like, okay, I know I need to substitute this back into one of my equations. It doesn't matter which equation you use, whether you use an equation before or after you multiplied, it really doesn't matter. What I like to do is just try to use an equation that's simple for me to do the math in my head. So I'm going to go ahead and try to do the top equation and see where it takes me to finish solving for y in this case. So I've got -10. Instead of writing x, since I already solved for x, I'm going to put -1 in its place, plus 3y equals 1. So now I have one equation, one variable I need to solve for y. So -10 times -1 is +10, plus 3y equals 1. And again, we're just doing the algebra at this point. So let's subtract 10 from both sides. You get 3y is equal to -9. Divide both sides by 3 to get y by itself. You get y equals a -3. So my final answer, you need both x and y, is -1 comma -3. Okay, so let's go ahead and do one more example. Okay, so now remember, the first goal is to make it so that you have same number but opposite signs in front of one of your variables. So I'm going to go ahead and analyze each of the variables to decide which one would be easier to work with here. So I'm noticing I have a 2 and a 7 to work with when it comes to the x's. And I don't think that there's a nice number to multiply 2 by in order to get 7, so I'm actually not going to do the x's. I'm going to focus on the y's. If I go through and multiply the bottom equation by 3, then I will have achieved my goal. So let's play this out. The top equation I did not modify, so I'm going to go ahead and copy paste it down here. So negative 2x plus 15y equals negative 32. Just rewrote it. Next, let's distribute that 3 to all of the terms. So I've got 21x minus 15, why did I write a 3? 15y equals 51. Now that I've achieved my goal, I have same number but opposite signs in front of my y's, positive 15, negative 15. Let's go ahead and do the elimination. So I'm going to add the equations together. Negative 2x plus 21x is 19x. The 15y and the negative 15y eliminates. And then negative 32 plus 51 is 19. Divide both sides by 19. You get x equals a positive 1. Last step here, we need to go through and figure out what is y. So I can substitute my x in for either equation. It does not matter which one. I'm going to go ahead and try the bottom equation just because the numbers look smaller, that's all. Let's do 7 instead of x, I'm writing 1 minus 5y equals 17. Okay, so 7 times 1 is a positive 7. Minus 5y equals 17. Subtract 7 from both sides. You get negative 5y equals positive 10. Divide both sides by a negative 5. And I get y equals negative 2. So final answer is positive 1 comma negative 2.